Hello everyone, happy to see you here. Today we have great, quick and relaxing algebra question. I would say like this is a really tricky one. K cube equal to k minus 1 cube. And we need to solve this question for k, so if you have your solution, your answer, your approach, you can also write it in the comments below. It will be really interesting. So a lot of students might be thinking, okay, we have k cube and right here we have the same third power, so maybe we can cancel this. So we have k equal to k minus 1. Yeah, we cancel everything, we can do it according to a property, and from here we have the 0 equal to minus 1. And a lot of students might be thinking, maybe right here we don't have roots, so yeah, this is our solution, no real number roots, no complex roots, 0 equal to minus 1, what is that? And they go to the next question. So in the end of the video, I will explain you this thing, why do you get this expression, and right now I want to show you how can you solve this question completely correctly and step by step. First of all, let's write this k cube on the left side. Without any changes, we have only one expression on the left side. What about our right side? This is our school identity, k minus 1 to the third power, not a classic one, not according to not square, but third power doesn't matter. So this is equal to k cube, so let's expand it, let's write it. So k cube minus 3k square plus 3k and minus 1. So right now let's write everything on the left side. So let's write equal to 0. This is extremely important part right now. So we have k cube minus k cube. So for everything from the right side but with the opposite sign. So minus k square plus 3k square minus 3k and plus 1 equal to 0. One really great moment, we can easily cancel this k cube, and as a result we have a classic quadratic equation, 3k square minus 3k and plus 1 equal to 0. Of course, this is up to you how you prefer solving this type of question. I want to solve it according to a classic method. Let's write our coefficient on the right side. So a equal to 3, b equal to minus 3, and c equal to 1. Okay, let's do it. So let's solve it for discriminant quickly. Yeah, we have b square minus 4ac equal to, so b square minus 3 square minus 4ac minus 4 times a times 3 and times c times 1. As a result, our discriminant equal to 9 minus 12 equal to minus 3. So it implies that in this branch, in this quadratic equation, we don't have real number roots, so I'm gonna cancel this sign, no real roots, but two complex roots, because our discriminant is less than 0. So we have two complex roots. And right now let's solve it. Let's solve for that complex root. So that's why we have k first and k second. We have two roots equal to minus b plus minus square root of discriminant and all over to a. So let's plug in everything we know about it. So minus b minus 3. So minus 3 plus minus square root of discriminant, square root of minus 3, and all over to a 2 times 3. So let's simplify it. Minus 3 equal to 3, yes, 3 plus minus square root of minus 3. Let's write it as square root of minus 1 as a product times 3, yeah. And of course in our numerator we have 2 times 3 equal to 6. Okay, right now according to a square root property, we can split it. We can write it as square root of minus 1 times square root of 3 all over 6. Okay, the next thing, we have 3 plus minus square root of minus 1. This is our imaginary unit, this is our I, and square root of 3, we'd leave it like that. So we have square root of 3 times I all over 6. Okay, what we're gonna do next? My quick recommendation, we can divide it by parts. We can say, of course you can leave it like that, but we can simplify this a little bit. We can divide both parts by 6. We can write 3 over 6 plus minus square root of 3 times I over 6 equal to 3 over 6 equal to 1/2. So we have 1/2 plus minus right here, square root of 3I over 6. We can simplify it. We can write it. We can multiply our numerator. So the same, I'm gonna rewrite it square root of 3 over times I over 6, and we multiply our numerator by square root of 3 and our denominator by square root of 3. Okay, so that's why this is equal to, so just look closely, square root of 3 times square root of 3 equal to 3. So we have, let's write it, okay, 1/2 plus minus, so we have 3I in the numerator, and in our denominator we have 6 square root of 3, 6 square root of 3. So as a result we can cancel this 3 and this 6. As a result we have our 2 in our denominator. So our final answer, 1/2 plus minus I over 2 square root of 3, 2 square root of 3. So as a result, in this branch we have two roots, k first and k second. So let's write our final answer to this question, and then I will explain you why you didn't get an answer, a correct answer in the beginning. So that's why. Let's write it. So our answer. So k first and k second equal to 1/2 plus minus I over 2 square root of 3. These both roots are complex roots, complex roots, and basically we don't have a real number roots. And right now, a few thoughts about our question from the beginning. First of all, I want to start with one really important moment, maybe the most important moment right here, because it calls we call it as fundamental theorem of algebra. When we have, for example, k cube equal to k minus 1 cube to the third power. According to a fundamental theorem of algebra, when we have the third power as like the highest power, it means that we have 3 roots in total. At least 3 roots in total, yeah? When we're talking about, for example, k to the power 4 equal to, for example, k minus 1 to the power 4. Okay, according to a fundamental theorem of algebra, we have 4 roots in total, 4 roots at least, not like a total, at least 4 roots at least. And according to this question, when we have k to the power 3, it means that we have 3 roots, we have at least 3 roots, like maybe 1 complex, 2 real, 2 real, 1 complex. And this is an extremely important thing, because when you see this type of question on your exam, you can't cancel everything and say, okay, right here we don't have real number roots. For example, if you don't have real number roots, maybe we have right here 2 complex roots, exactly our case. This is an extremely important part, and I really hope you understand it. The fundamental theorem of algebra is an extremely important thing on your exam. This is an easy thing. I hope you understand it. And the next thing I write in the beginning, I wrote that we had something like that: k cube equal to k minus 1 to the power 3. And as I said before, a lot of students cancel this 3, and they say k equal to k minus 1, and we have 0 equal to minus 1. This is a wrong way, because when you cancel this 3, you cancel your roots. So that's why the best way to solve this question, when you have, for example, third power, then write everything on the left side, and as a result we have difference of cubes, maybe sum of cubes, maybe difference of squares, exactly our case. But we solved it in a different way. We just expand this k minus 1 to the third power, and we cancel this third power. Okay, so that's why my quick recommendation, maybe in the end of this thing, I want to say you that when you have an expression, try to factor something, try to write it everything on the left side, and don't cancel, because when you cancel it, you forget about roots. When you cancel these 3, you cancel your roots. That's why when you cancel it, you forget about these two complex roots. Okay, so I hope you understand my solution. I hope you understand a few thoughts about it. This is extremely important part. First of all, my quick recommendation: do not cancel this. Second recommendation: learn about fundamental theorem of algebra, because it helps us to know the amount of amount of roots. When we have third power, it means that we have 3 roots in total. We can have like 1 real, 2 complex, 1 real, maybe 2 complex without real roots. And the same thing right here. When we have k to the power 4, we have 4 roots, in total. It can be like 1 real, 3 complex, 1 3 real, 1 complex, a lot of different combination. And if you solve the question, for example, with a third power without any real root, it's really weird, and you need to review a little bit your your knowing of this of the theorem, which is extremely helpful and extremely great. And yeah, if you have, for example, k square, if we have a classic quadratic equation, what does that mean? It means that we have k square, it means 2 roots. Yeah, we have right here our quadratic equation. Yeah, so we have 2 roots. If we have third power, we have 3 roots. In our case, we have 2 complex roots, but it happens sometimes that we don't have real number roots. These graphs does not intersect with each other, so with the cubes, k cube and k minus 1 does not intersect with each other, so it means that we have 2 complex roots. So thank you for your time. Take care of yourself. Have a great day. Write your thoughts, write your thought. What do you think about this type of question? What do you think about this solution? It will be really interesting to read about it. So wish you all the best in life. Take care of yourself. Have a great day. See you in the next videos.